Now the next example that we are going to study is, it is a motor housing cover which is made up of polyethylene, and it is subjected to a heat flow of 5 watts for 10 seconds on all the inner faces. Okay, and the convection among the outer faces is of stagnant air, where the ambient temperature is 25 degrees Celsius. We are supposed to calculate the maximum temperature induced and the amount of heat lost or heat gained. Now in this case, if you notice that the load, that is the heat flow of 5 watt, is acting on the body for 10 seconds. That means time is coming into picture over here in this example. So this is a transient thermal analysis that we have to perform. Okay. So now let us understand what is transient thermal analysis. As we discussed previously, transient thermal analysis is nothing but that thermal analysis in which the temperature acting on the temperature loads acting on the body are time dependent. Okay. So now let us see how to perform this analysis in Ansys Workbench. So we will come to the Ansys Workbench software, and now in this case I am going to add transient thermal analysis system to my project window. Okay. Now in the problem it is mentioned that the material that we are going to use for this cover is polyethylene. So we will add that material and then we will return to the project. Okay. We will just study the material properties. You can see over here that the thermal conductivity is present. Okay. Now let us add the geometry. Now again in this case the geometry has been created in the CAD software. So we will just import that. So now the geometry has been imported. Just have a look at the geometry, whether it has come properly or not, whether if there is any data loss. We will set the unit system and then we will generate the geometry. So you can see that the geometry has been imported correctly. Okay. Now again in this case the thickness of the model is very small, so either you can consider this to be a 3D problem or you can also solve it as a 2D problem. Okay, but we will consider this to be 3D only, so that I am able to apply these loading conditions properly on the inside and the outside surfaces. Okay. Now that the model is ready, we will enter into the mechanical model. Now when you are performing transient thermal analysis, all the steps remain same except the analysis settings. You need to specify the time and the time steppings correctly so that you get the correct results. Okay. So the first thing that we are going to do over here is we will change the material for the model. So I am going to apply polyethylene material. Then we have to mesh the model. So I will click on mesh and I will update the mesh so that I get the default meshing. Okay. Once the default meshing is done, you can change it to proximity or you can change it to curvature so that the meshing is finer. Fine. So once the meshing has been done, now we will click on transient thermal node and we will apply our boundary condition. Please understand the heat flow that is acting on the body is for 10 seconds. Okay. So now see how to perform this. We need to take a heat flow, select the face where it is acting. It is acting on the inside faces. So we have selected the inside faces. Okay. And it is the value is 5 watts, but it is acting for 10 seconds. So now where do you enter the timing? If you notice over here, it is only for 1 second. So to increase the time, what you need to do is click on the analysis settings option, and here you can see in the details of analysis settings, you can see number of steps as 1. So change this to 10. As soon as you change this to 10, you will see steps and the end time. So you can see that the end time is now 10 seconds. Okay. After this, you have to specify the steppings, means from 0 to 1, how should the time vary? Means, do you want to record your results for each second, or at 0.5 seconds, or each milliseconds? How do you want to record your results? So for that, you need to specify something which is called as automatic time stepping. Now this is very important, so that the software knows how do you want to record your results. Okay. So by default, this option is always on program control. When it is on program control, the time steppings are controlled by the software. If you see, the time stepping over here is 1 e raised to minus 2. That means the stepping is 0.01. Okay. So the results will get recorded as 0 to 0.01, then 0.02, 0.03. So you will get in 1 second only, you might get somewhere around 650 to 100 results. So you will get a lot of results. But if I don't want such a small time stepping, you can change it on your own. So for changing it manually, you should change this option to on. Auto time stepping should be on, and then now we can manually change these values. Okay. Now when you see, currently we are on step number 1. That means we are going to edit step number 1. So from 0 to 1, I need to have the time stepping as 0.2. The maximum and minimum should be same, and time step should be of 0.2. So I've kept everything on same, so that the time stepping is of 0.2. So the answers will get recorded from 0 to 0.2, 0.4, 0.6, 0.8 and 1. So in 1 second you will get 5 results. So total for 10 seconds I should get 50 results. Okay. But now the same thing has to be done for first step, second step. Okay. So each and every time I will have to come over here and change it. So instead of changing it one by one, if you want to have the same time stepping for all the steps, select them all, select over here, right click, say select all steps, and then come over here in automatic time stepping, switch it on, and then give the time stepping. I'll say it has to be 0.2, 0.2 and 0.2. So now whatever we have done over here has got applied to each and every step. You can see, you can click and you can notice the changes. Okay. So this is a very important step in transient thermal analysis, where you need to mention the number of steps which decides the total number of time, and then you have to change the time stepping over here. The same changes you can also do, or the same steps you can also apply in transient structural analysis, where the force will vary with respect to time. Okay. So it is the same thing you can also use in transient structural. Okay. Now that we've understood how to set the time, we have also set the time. Now we will again click on heat flow. So you can see the heat flow, the time steps has increased to 10. Okay. Now let us say if it is constant throughout the analysis, we will keep it as 5 only. Or else let us say at 0 seconds the values are different. We can change it like that also. Initially we will just keep it like this. And now we have to also apply convection. So there is convection on all the outside faces. So we have selected all the outside faces. Apply. The ambient temperature I mentioned is 25, and again in this case I am going to import my convection data. Okay. And then we will solve. So for results, in the results we are interested into the temperature induced and the amount of heat loss or heat gain. That I can calculate using the reaction. So let me add the temperature, flux and the reaction. So due to convection, what is the amount of heat loss? Now let us solve. So if a heat flow of 5 watts is applied on the object for 10 seconds, what will be the results? So you can click over here and you can see that if the heat flow of 5 watts is applied for 10 seconds, the temperature induced is 27.649 degrees Celsius. The reaction probe, you can see the amount of heat lost or heat gained over here. Okay, and the max heat flux is this. You can see the vector plot, arrows will be visible, and you can see the animation which will show the direction of heat flow. Okay, so this is how you will perform a transient thermal analysis. Now let us say, you can see over here the results that have been recorded. Totally we have 50 results. So we have in between also at 1.8 second what is the result, and I can retrieve this result. So I can say, I can see very clearly at what time what is the result. See, you can see over here. Let us say I want to see the result at 1 second, at the first second. I can right click and say retrieve this result so that the plot changes according to that. So we can see minimum and the maximum temperature both. Okay. Now let us assume that the heat flow, according to the problem, we don't have any changes. But let us say if I want to change, at 0 second the heat flow is 1.2. At 1 second the heat flow is 1.8. Then it increases to 2.2, 2.5, 3.2. So I'm changing at every second. 4, 4.2. Okay, then it becomes 4.5, 4.8, and finally 5. So I have changed the heat flow values at every second. So you can see the graph of the heat flow. And now if I solve my analysis, so previously when we saw it was 27, maximum temperature induced was 27 degrees Celsius. Now let us say how much is the temperature. So it is only 22.36 degrees Celsius, 362, right? Because starting from 1.2, it gradually increases to 5. Okay, so this is the temperature distribution. If the heat flow is also gradually increasing. Okay, fine. So this is how you will perform a transient thermal analysis in Ansys Workbench.